Hi everyone. Today in our notes we're going to talk about nutrient cycles. There's two nutrient cycles that we're going to talk about today. The first is the hydrologic or the water cycle, H2O, and the second is the carbon cycle. And really our goal over the next couple of days is to look at the way that matter cycles through ecosystems. So another word for a nutrient cycle is a biogeochemical cycle. So let's take a look at this word. So we have this root word bio. Bio we know means life. We have another stem here, geo. Geo means earth. And then chemical, this is obviously talking about chemicals. So when I say a biogeochemical cycle, I'm talking about the cycling of chemicals through life and the earth. So this is where we find these different chemicals or elements, both within living things and around the earth in other ways. So it might be in soil, or it might be in the air, or it might be in the ocean water, or things like that. So when we're looking at biogeochemical cycle, so here's our formal definition. So it's the exchange of matter. So this is important. It's the exchange of matter through the atmosphere, involving living organisms, chemical processes, and geological processes. So we see the cycling of matter that happens. We're going to study 3 of these natural cycles. So we're going to talk about the water and the carbon cycle today. We're going to talk about the nitrogen cycle next week. And something that's really important for us to take note here is this law of conservation of matter. That matter cannot be created or destroyed. I can't just make matter out of nothing, and I also can't destroy matter. So if that matter goes away, right? If it goes away, then it's not really going away. It's just being transformed into something different. So let's start talking about the water cycle. So here with our water cycle, there are lots of different steps in this process. One of the, and the water cycle should be pretty simple. You guys should have studied it before, so we're going to breeze through this pretty quick. So we have evaporation. So when we go from liquid to gas, so this can happen off of land, like we see in the diagram. It can happen off of the water. We can even have ice evaporating, melting and evaporating up into the atmosphere. So now we have water vapor in the atmosphere. In the atmosphere, that water can condense, so it can turn back from a gas into a liquid. So that's when we get these clouds up in the atmosphere, that condensation. We can have precipitation. That's when we see water falling from the sky. So rain, snow, sleet, anytime we have water falling from the sky, that's precipitation, part of our water cycle. Transpiration is one that might be new to some of you guys. So transpiration, it's similar to evaporation, but this is when we see the evaporation off of the leaves of plants. So this is a specific type of evaporation from a specific location. So when I have a plant, and here's my nice green leaf, this leaf actually has these little pores, and we can actually have water evaporating from these pores in this plant. And that's actually a very important process. It's part of how water actually moves up from the soil through the roots and then up the body of the plant. So we have transpiration happening from the leaves. And then infiltration, this may also be a new word for you guys. So infiltration is when we see water soaking into the ground and contributing to groundwater. So we have groundwater. This infiltration can also kind of seep in and go to the oceans. And then finally, I don't have it on here, but we can also have runoff. So when we see that water precipitate, it can also run off the land and then into our open bodies of water. All right, so again, here's just another diagram. If you want, you can pause the video and take a look at this as well. So water within the water cycle, it's going to spend different amounts of time in different areas, okay? So these different areas where water spends time, we call a reservoir. So here's our definition. So it's an area where water will remain for a certain time frame. And we look at that time frame, it's our residence time. Here are different residence times for different things. So we notice that some things that there's a really long residence time for. Water is going to spend a long time hanging out in oceans. Water is going to spend a long time as deep groundwater or even shallow groundwater. So those things really hold on to water for a long period of time. Other areas, so rivers don't hold on to water for very long because those rivers will eventually flow into lakes and into the oceans. And the atmosphere also doesn't typically hold on to water for very long. It's going to evaporate up into the atmosphere, condense into clouds, and precipitate relatively quickly. So we can see really those varying residence times in our different reservoirs. All right, the next cycle I want to talk about is the carbon cycle. And really, the carbon cycle, we see carbon stored in organisms or stored in the Earth's crust, or we see it as carbon dioxide in the atmosphere. So there's a couple of different processes that are going to happen here. And the carbon, the C in our different compounds, is what we're looking for in the carbon cycle. So here I have CO2 going to the atmosphere, to the ocean. There's a bunch of different processes that actually do that. The first is actually decomposition. So when we have dead material that's breaking down, so here we can see it in the diagram here, it's shown as decay. When dead material breaks down, part of that decomposition process, it actually releases the carbon from that material into carbon dioxide in the atmosphere. So we see that transformation into atmospheric CO2 happening, okay? Need to choose a different color. So we see carbon dioxide in the atmosphere from that decaying matter. The matter from those decaying organisms doesn't just disappear. A lot of the carbon actually gets converted into that atmospheric CO2 through decomposition. Another way that carbon dioxide can get into the atmosphere, into the ocean, is combustion. So by burning things, and this could come from a couple of different areas. So we could burn carbon-containing products like wood products or paper. So anytime we see the burning or combustion of wood, we're going to put that CO2, that matter is going to go as a gas into the atmosphere. And when we burn fossil fuels, we also release carbon dioxide. We release the carbon that was stored in those fossil fuels out into the atmosphere. All right, and then finally we have cellular respiration. So this is when consumers like you and me, and really trees and producers also do this, but it kind of has like a net negative, so they also take in CO2, so we don't typically think about that. But here, our consumers, they're going to be using energy and using oxygen, and a waste product of this process is carbon dioxide. Really what's happening is glucose, which is chemical formula C6H12O6. Here's my carbon. When cellular respiration happens, these carbons get kind of chopped off and they get rebonded into this carbon dioxide CO2 molecule. So this is what's being given off into the atmosphere. So when you breathe, you're breathing out that CO2 into the atmosphere. So we're contributing to that CO2 up in the atmosphere. And even it's weird to think about, if somebody's losing weight, where does all that mass go? Where does that matter that made up your tissues go? Where it's actually going is out into the atmosphere as CO2. So it's kind of weird to think like when I lose weight, I'm really just like breathing out that extra mass, but that's essentially what's happening, which I think is kind of interesting. We also see carbon dioxide being exchanged with the ocean, with water. So that's why I see up here the atmosphere and the ocean. We also see kind of a back and forth. Carbon dioxide can actually be dissolved into ocean water. So we see CO2 in the ocean, or it could come back out into the atmosphere. So it can kind of go both ways here. CO2 in ocean water, this is actually what causes ocean acidification. The more CO2 there is in the water, the more acidic the ocean water is going to be. All right, so then there's also ways for us to store carbon. So to pull this CO2 out of the atmosphere and store it in other stuff. One of the big ways that our planet does this is by photosynthesis. And notice how there's really only two ways to get carbon dioxide out of the atmosphere. We can either exchange it into the ocean, or plants pull it out through photosynthesis. So this is the opposite of cellular respiration. So we take that CO2, we react it with water, and that is going to give us a glucose molecule and some leftover oxygen. So here's that C6H12O6 again, that glucose molecule. So there's my carbon, okay? So here we're taking carbon dioxide out of the atmosphere and we're locking it away in that sugar molecule. And that is going to get passed around in living ecosystems for a while. So that carbon, it can stay in some plants for a while. An animal can come and eat it. Then that animal might breathe it back out into the atmosphere through respiration. Or that animal might die and then it goes back out into the atmosphere through decomposition. Or let's say a plant dies, and really this happens with phytoplankton in the ocean. So phytoplankton dies and sinks down into the deep ocean, and a bunch of stuff piles on top of it, and there's lots of pressure and lots of heat and lots of time. Eventually we can actually also turn this stuff into fossil fuels. Okay, and this process we call deposition. So when we see really ocean organisms like these phytoplankton photosynthesizing, dying, becoming sediment, getting buried, okay, and then for long periods of time eventually with lots of heat and pressure can become fossil fuels like coal, oil, and gas. So this is another really good way that our Earth can store that carbon other places other than in the atmosphere. Then we humans might come along, we dig it up, and then we burn those fossil fuels, and then there that carbon is going back out into the atmosphere. So that's why this is a cycle. So we can see really that cycling and the rotation of this matter through the ecosystem. All right, if you guys have any questions, go ahead and leave them at the end of the video. Tomorrow we'll do a little bit of a review, we'll do a quick warm-up, and then we're going to do some practice with our hydrologic cycle and our carbon cycle, and taking a look at some different ways that we can cycle this matter through our ecosystems.